Hello and welcome to my channel Mathemagica. This is Shreya and today we'll be discussing a problem on number theory. Let's have a look. So, you can see that it is given that a natural number is first divided by 11, okay? And the remainder is 2, right? Now, that very number is raised to the power of 2025. So now the question is that this number raised to the power 2025 when divided by 11, what will the remainder be? Okay? So let's move on to the solution. The information that we have about this number is that this number when divided by 11 gives us a remainder of 2. Okay? So now we can then say that let this number be n, capital N. So capital N is of the form 11x plus 2. Makes sense, right? Now, this number, capital N, is raised to the power of 2025. So, what will this be equal to? This 11x plus 2 whole to the power of 2025, right? Now, let's revisit binomial expansion. We know that a plus b whole to the power of n. What does it give? It gives us n c0 a to the power of n plus nc1 a into b a to the power of n minus 1 into b plus nc2 a to the power of n minus 2 square plus blah 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 plus ncn minus 1 a b to the power of n minus 1 plus ncn b to the power of n. Right? Similarly now, this 11x plus 2 whole to the power of 2025 can be written as 2025 C0 11x whole to the power of 2025 plus 2025 C1 11x whole to the power of 2024 into 2 plus blah 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 plus 2025 C 2024 11x into the power of 2024 plus 2025 C 2025 into the power of 2025. Got it? Now, you see that you have powers of 11x here in the first term, in the second term, then in the third term, fourth term, fifth term, dot 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 up to the second last term, right? You see? So from the first term to the second last term, we see that these are all multiples of 11, okay? Because all of them have this 11x, right? So can we write it as 11 sum into sum m plus 2025 C 2025 is 1, right? And this gives 11m plus 2 to the power of 2025. That is equal to our n, which is n to the power of 2025. Okay? Good. Now, our problem is decoding this 2 to the power of 2025, right? Because when we will be able to decode this then only we'll be able to find what the remainder would be when this n to the power 2025 is divided by 11. Alright? Okay. Right. So, 2 to the power of 2025, that is our problem over here now. Okay? So, we have to find a way to decompose it so that we can again bring it in terms of 11, right? What is that number which is a power of 2, which is very close to a multiple of 11? We have to check that. 2 to the power 1, 2 to the power 2, 3, 4, 5, right? 2 to the power 5 is 32 and 33 is a multiple of 11, right? So, what we get the power of 2025 can be written as 2 to the power of 5 whole to the power of 405, right? Now 2 to the power 5, what is it? This is nothing but 32, right? 32 is what? 33 minus 1 whole to the power of 405. Now, to find out 33 minus 1 whole to the power 405, we go back to binomial expansion. Okay? So, a minus b whole to the power n, what is it? It is nothing but nc0 a to the power of n minus nc1 a to the power of n minus 1 b plus blah 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 something plus minus 1 whole to the power of n minus 1 nc n minus 1 a into b to the power of n minus 1 plus minus 1 into the power of n nc n into b to the power of n. So, here also, if you see, from the first term to the second last term, you have a, powers of a in each term. Okay? So you can say that from the first term to the second last term, every term is a multiple of a. Okay? So now we'll apply this information and write 33 minus 1 whole to the power of 405. Following the similar logic, we would write 405 C0 33 to the power of 405 plus 405 C1 33 to the power of 404 and the minus sign, sorry, so minus sign here, plus blah blah blah. Then the second last term, which is minus 1 whole to the power 404, which is a plus 405 C404 33 minus 405 C405 into 1. Okay? So, again, from the first term to the second last term, we see that each term contains powers of 33. Okay? So, each term from the first term to the second last term is a multiple of 33, which in turn is a multiple of 11. Correct? So now we can write it as sum 11a minus 1. Okay? So we found out that 33 minus 1 to the power of 405 is nothing but some 11a minus 1. Okay? So what can we say now? That we can further deduce it. Okay? How? 11 into a minus 1 plus 11 minus 1, right? So we have 11 into a minus 1 plus 10. So now if we were to write this whole thing n to the power of 2025, we'll write it something like this way: 11 into n plus a minus 1 plus 10. This is or we can say this is the form of n to the power of 2025, right? So this is also some natural number, and this 10 is our required remainder. So the answer or the required remainder is 10. Thank you for watching.